Okay, so how the internet works. The internet functions as a large phone book or digital directory. So it can take numbers and turn that into a text or like text into numbers. It's pretty awesome how the internet can work. They use what's called a node, and this is like how the internet routes protocols. So, which we'll get into later through the semester. Computer and softwares use logical addresses at the port of numbers, so communications are directed to and from. So it has to be a logical address to get a website to work or not to work. Services communicated with each other on the same computer and other computers connected to the network, but the rest of the underlying communication that powers the web are transparent to users. So, the simplest form of the web is composed of interlinked hypertext documents, aka a website, that is accessed through web browsers like Google Chrome, Apple Safari, Firefox, Microsoft Edge, and the infamous Internet Explorer that no one uses anymore. The World Wide Web represents only 1% of the entire internet, which means the dark web and the deep web make up everything else. Now, think about that. The www you probably have used all the time. And think about how much information is on that. That's only 1%. The dark web, which if you watch like Criminal Minds or SVU, the dark web is a part of the World Wide Web content existing on an overlay of networks which use public internet, but they require specific software configurations or authorization to access. The deep web is a part of the World Wide Web whose content is not indexed by standard search engines for any reason. The deep web is the opposite of the World Wide Web. So it's not going to come up on Google, on Safari, Yahoo, Bing. It's not going to come up there because it's not a standard search engine. So you probably have heard of a URL, which is a uniform resource locator. If you want to tell your friends, oh, I need to have your uniform resource locator, they'll probably look at you and be like, what? But it's a URL. URL falls under a URI, which is a uniform resource identifier, and they are basically just the building blocks for the World Wide Web. They're web pages, and they all are specific to a certain web page. No web page has the same URL. So they are very specific for the location, so the computer networks can retrieve it based on this huge mechanism. So the URL is a representation of a URI, and although many people use them interchangeably, they're kind of different. Common internet technology terms, do not be overwhelmed when we go through this list. You're going to get more comfortable throughout the semester. This is the first chapter, so don't panic. A domain name. This is a location where the collection of web pages can live or pages live, and when a topology or mapology of a domain. A domain name service, or DNS, is a distribution of global registry that resolves domain names on internet IP addresses and vice versa. Servers. Servers are computer programs or mechanisms capable of accepting requests from clients and responding to them. IP addresses, which everyone has, they're also called Internet Protocol. This is a numerical label assigned to each device, so a computer, a printer, cell phone, fax machine, basically anything that you can use to connect to a computer network that uses the internet for communication. And a web browser. A web browser is a software application for retrieving, presenting, and transversing information resources on the World Wide Web, aka Google Chrome, Apple Safari, Firefox, everything else. Transport Layer Security, or TLS, this is a protocol that ensures privacy between communicating applications and their users on the internet. We're going to go in a lot about security. It is a very hot topic in government right now, especially for the online services. Web host, or a web hosting. This is a service for a type of internet hosting that allows individuals and organizations to access the website via the World Wide Web. And a web host are companies that provide space on a server owned or leased for clients, as well as providing internet connectivity, typically at a data center. So I use Comcast to connect to my Wi-Fi, and then I have Dropbox for data centers. I rent my Wi-Fi, I pay my bill, and then I also have like a bill for Dropbox to expand like how much service I have to store all this data that I collect. A file transportation protocol, or FTP, is a method for copying, moving, renaming, or or deleting files on a web server. And then we have cloud computing, which you probably are familiar with. The cloud is an interworked collection of resources that are often shared by multiple users or dynamically reallocated per demand. If you are probably more familiar with the Apple iCloud, you can share that with your family, with your friends. You can have your cloud shared on a different devices. It's pretty interesting. There's also other ones, like I talked about a second ago, Dropbox. Dropbox is also a cloud that I personally share with some of my faculty members for the purpose of research. So let's talk a little bit about web analytics. Web analytics are platforms that are used to understand the activities for users on specific websites. So you can track behaviors like where people are going, what they are searching, how they're clicking, what are the hottest topics on a web page. It's so interesting when you can start diving in and honestly look at the consumer behavior aspect in an online environment. Text analytics are the process of turning text into numbers, similar to the structure of spreadsheets, so that statistics and other types of analysis can be ran. So we're really going to dive into text analytics in a certain chapter, but I want to just kind of briefly put this more into terms that you may understand better. There are softwares that can take, for instance, Yelp. Yelp, you can write a review and they will look at that text and rate it 1 through 5. And 1 being bad, 5 being good. But you don't even have to say 1 through 5. You could just say this was the best place in the whole entire world to eat. My server was phenomenal. And they can break that down word for word and rate the server, how they did, what they did, the restaurant. And then they can put that number into a spreadsheet so data can be ran. Pretty cool, right? Search analytics. This is the analysis of organic or paid search engine results. Search engine analytics include the analysis of a search site result on a search engine running on a specific website. So this is when you can either have organic means it's free. You have done a really good job probably on search engine optimization, which we will get to again later in the semester, but you probably are in the top 3 when you type in best dog groomer in town. If you're in the top 3, you're doing really well on your search organic results. That does not mean the promoted ones that have been promoted. That is paid search engine results, which also go into search analytics. So here's just a little chart of how web analytics has progressed over time. So web analytics really began in 93 and has progressed up until today. Page tagging and tag management systems and services such in JavaScript came in 1999 and really progressed and took off up until 2004. In 2004, web analytics really started maturing more, and then social media came about with Facebook. Now, social media did not take as long to progress with their analytics because we already had web analytics. So people could already go back and look at the topics that they wanted to track on social media, and it didn't take as long for that to progress as web analytics did. Then we had the emergence of data and digital analytics and big data, such as artificial intelligence, text mining, sentiment analysis. I know these words sound very confusing right now, but they will be so easy and ingrained in your mind by the time you're done with this class. So data, now called the new oil or digital gold, this is the term data is the new oil, which reflects the current consensus that most people consider data as such a huge asset like oil. It is big. For an example, credit card companies are using unusual spending patterns for their customers because they're using sophisticated algorithms to examine massive data sets and saving customers billions of dollars a year. Yeah. Major retailers are using unstructured data and collecting customer transactions to refine their online search engine and encourage customers to buy more products. And we will get into that a whole lot this semester. And then food and beverage suppliers merge customers' logistics and manufacturing data to improve their plant operations significantly. So they are looking at outside data of how things have progressed, and then they're taking it and putting it back into their system to make their plant operations costless. Pretty cool. Digital advertising is spending growth. So this is kind of just a little chart you can see here. The blue is digital spending. The little orange line is the percent of change. And then the blue, like the bluish gray, we'll call it slate gray, is the percent of total media ad spending. So online marketing has rose to match businesses' new strategy of staying connected by increasing the resource and capabilities of a consumer that a consumer could perform. So we won't get into a whole lot of this, but I just wanted to throw this kind of little digital ad spending. And this is from 2015 to 2020 in billions. So in this chapter, we really just kind of talked about the introduction of a lot of terminology that probably overwhelmed you at first. Do not stress out. You will get this. We looked at some essential constructions of digital analytics, what's possible, and the development of the internet and World Wide Web. We also looked at some technology that powers our digital experience and that's like can be broken down. At this point, we are painfully aware of the mechanisms for computing information, such as clients and servers and internet routing protocol and so on. There's a lot of information in this chapter. So I want you to look at these questions and just kind of go through and see like, okay, yes, I know this, I know this, I know this, I need to study this. You'll probably see these on your test. What are the main differences between the Web 1.0, 2, 3? If you want to go ahead and add 4 in, I'd be very happy. Explain the differences between web clients and web servers. And then what is cloud computing? So just kind of run through this. If you have any questions, please review back to the PowerPoint. And it's just kind of really good to know. So I hope you all have a fantastic week, and I will talk to you soon.